Hello and welcome to today's broadcast, leveraging real-time industrial IoT data from across the plant floor for BI across the enterprise. I'm Carol Gunz, Director of Marketing at Attunity, and I'll be your host today. Before we get started, I just wanted to review a few things. All attendees are in listen-only mode. If you have questions, please type them into the chat window and we'll work to answer all of them at the end of this session. This session is being recorded, and in the next day or so, you'll be getting a link to the recorded version of the webinar. And now, let's get started. If you could just switch to the next slide. Today's speakers are Michael Gurr, General Manager, Automotive and Manufacturing Solutions at Hortonworks. We also have Wayne Summers, Manufacturing IT Specialist, Symmetric Instruments, and Jordan Martz, the Director of Technology Solutions at Attunity. Next slide. And today, you'll be learning how leading companies are connecting to and analyzing ever wider sets of industrial machine and sensor data to hear the voice of the factory. You'll also learn about collecting manufacturing and enterprise data within data lakes to drive generation insights across enterprises, next generation insights across the enterprise. And lastly, we'll talk about creating high-performance industrial data pipelines to ingest and analyze manufacturing data in real time. And now, let me turn it over to Michael Gurr.
Correct. Thank you, Carol. And also thank you to Jordan and Wayne, both great partners, and we all look forward to presenting to you today. So let's talk about why the industrial Internet of Things is important. And you know, it's important to keep in mind that it's not important for the sake of technology, right? At the end of the day, all of these things are important because these types of technologies can help you improve your business, right? So if we just step back for a second, you know, manufacturers have forever been tasked with improving quality, right? And for good reasons, right? The cost of poor quality, as you can see on the screen, amounts to about 20% of sales, right? So there has to be a concerted effort to reduce that. In the semiconductor world, you see that manufacturing yield, you know, actually directly impacts profitability, right? So these types of issues really have to be addressed. At the same time, you know, where Industry 4.0 and being able to collect machine data and all those types of things can help is addressing the whole issue of plant uptime, right? And you start to see use cases like predictive maintenance and all those things. And again, they're not important for the technology perspective, but they're important because they can help you drive business results, right? So quality, yield, machine uptime, that's why we're really here to what we're really here talking about. The interesting thing is, despite the fact that an industrial Internet of Things or Industry 4.0 can help in these areas, we find that, you know, McKinsey finds that only 16% of manufacturers have actually adopted an industrial IoT strategy. So I think the key takeaway of all this is it's really important, yet a lot of companies are just starting the journey, and that's where we hopefully can, you know, we collectively on this phone can help. All right, so as I said, you know, these are age-old problems, right? So what's new? What is IoT, and you know, and how is technology really transforming these problems? Well, one of the things we see is due largely to the fact that manufacturing sensors have actually decreased in cost by about 2/3 over the last decade. We see that industrial Internet of Data or Industry 4.0 types of data is projected to grow twice as fast as any other data source, as any other big data source, including social media. So just think about that for a second, and you start to think about the types of data volumes we're talking about, right? Good news is that we've got technologies now that can store this type of data, right? And this, you know, this wide variety of data as well. So, you know, for years, manufacturers have been dealing with this notion of OT-IT convergence, right? Taking the machine world and sensor data and all those things and blending it with enterprise transactional data, things like MES systems, things like ERP systems. Well, now you have to do all of that plus bring in new types of data sources, images, videos, maybe correlating it to social media data, right? So, big data volumes in the environment right now, lots of data volume. The other thing that technology is really happening is, now we've got the capability to store all of this data in data lakes, which we'll get to in a second, but we also have the ability to process all of this data, right? So that you're going to start to see, and we'll talk about this in a second, that we can, once we have this data, we can actually comb through all this data, this huge volumes of data. We've got the computing horsepower to do it, to find patterns in the data that will ultimately help you optimize your manufacturing operations. And again, we'll get to that in a second in terms of exactly how we do that. But the point is that, now that we can actually collect all this data, we can process all that data, it's allowing us to look at analytics much more from the lens of enterprise process optimization. So we're going away from just, say, optimizing the uptime of an individual piece of equipment to having discussions about, how can we improve manufacturing outcomes, quality outcomes, or machine or factory throughput outcomes from an end-to-end perspective. So we'll talk more about that as we go forward as well. So again, technology really is driving new approaches to addressing those age-old problems that we talked about on that first slide. So when we look at it from a data management perspective, I think we're struck with two competing challenges, both of which prevent companies from getting a complete view of their manufacturing operations. First of all, is this whole notion of real-time information. So that's the OT side of the equation, right? Sensors, PLCs. Hey, that information is hard to get to. It's hard to connect to. And because of that, a lot of times this data sits either in the machines or in data historians. But at the end of the day, they're really not leveraged more broadly than that. At the same time, we have the traditional types of IT types of solutions, right? The relational database types of solutions, from ERP systems, MES systems. Those systems exist in their own silos. As a result, where the business would really like to be able to get to all of these types of information, they can't, right? And that leads to ultimately an incomplete view of their manufacturing processes. And it's easy to say that, but the real issue is that you can't answer really simple questions like which process variables predict equipment failure, or which process variables actually affect my quality and yield, right? So data silos and the inability to really bring all of this data together for analytics negatively impacts businesses. So, how can we kind of get around that, right? And, we're going to propose to you something that we're going to call the connected manufacturing data lifecycle that actually addresses the shortcomings of the slide, the previous slide. And fundamentally, to do that is that we're going to bring together those two types of data that we talked about. So the real-time data sources that you see on the top, from your PLCs, your SCADAs, your historians, and the OT and the IT information from your ERP systems, your MES systems, your quality systems, and all those types of. The trick is, first of all, to be able to ingest all that data, right, and put it into a manufacturing data lake that can store a wide range of data, right? You're no longer in a proprietary type of database that can only store a segment, a certain type of data. Manufacturing data lakes can store any kind of data, and you don't have to actually define a schema first. It's something called schema on write, right, where you can actually just dump the data in without predefining a schema. So get that information. We can ingest it very easily, and then we can store it. And then, by the way, one of the things that's really great about a manufacturing data lake is that we can actually perform data processing workloads directly within the data lake. So you don't have to move data out, right? So you can do all of this processing within the data lake. We'll talk about that a little bit more in a second. But then you could also, from the data lake, you can do all kinds of what I call basic BI, right? So you could set up things like operational dashboards and all that kind of stuff. You could get to the information easily. Now that's interesting, but the real opportunity really is, and what we see people using data lakes for, is the fact that now that we've got these long histories of data, right? We're storing all this type of transactional data, sensor data, we now have the ability to learn from that data. So we're storing this long histories, we can start to see patterns in it, and we can start to actually do some analytics on it in terms of machine learning to say, hey, what were the actual manufacturing variables? Was it humidity? Was it time of day? Was it when you had shift turnovers? What was it seasons, right? You can actually pull all that information together and actually determine, for example, which variables actually drove successful quality or yield outcomes, right? Now, once you learn that model, once you develop that model and determine those variables, you can then deploy that model out into the real-time data stream, into that ingestion stream we talked about, where you could actually then monitor that incoming data for those combinations of variables that can cause problems. So you can, and the good news is not only can you monitor it, when those things happen, we can alert you, we can take all kinds of actions so that you can take actions in real time, right? So this is what we call the connected manufacturing data lifecycle, and it allows you to become a real-time organization that you're taking actions in real time based on the learnings of the past, right? And that's really what machine learning is at its core. Okay, so that's all great. And the thing that's really neat is that, in a data lake, it's not only about putting manufacturing data, right? We can actually put in data of all different types of data. So for example, if we want to figure out, we could pull in CRM data, for example, and we could then start to correlate which manufacturing factors or characteristics or manufacturing timeframes actually correlated to high customer satisfaction, right? Which ones actually, when we manufactured with certain characteristics, which ones actually impacted sales? Same thing with from a service perspective. When we had, for example, quality problems in the field or returns, right? Can we correlate back to the manufacturing conditions of the day to figure out what exactly caused that? Kind of a backwards correlation is we can say, hey, what manufacturing specs drove manufacturing outcomes? What engineering specs drove manufacturing outcomes? The point here is not only are we optimizing manufacturing operations into itself, but we're actually now being able to optimize processes across the enterprise, right? And that's really one of the big advantages that you start to achieve when you create these enterprise data lakes. So some of the sample, just looking purely at manufacturing, some of the use cases that we're seeing prevalently in the field, and these range from simpler to more complex. First of all, we could pull in all that manufacturing data, that sensor data that we talked about, and we can start to create things like process monitoring dashboards. Important and interesting, but this actually gets more and more interesting as you go along, as we move up in complexity. The other thing it allows us to do, use cases that we see, is what we call Process 360. And that's simply customers now, once they set up that data lake, being able to get a single point access to all critical information for analytics. So this is where you can, for the first time, bring in your sensor data and correlate it to my work order data, where I could correlate it to my production rates, right? All very easily because all that data is residing in the same place. So that's kind of, we'll call that process 360. But then we start getting to use cases like we'll call quality event forensic analysis, right? Where we start to be able to go move backwards. And so when we talk about forensics, we say, hey, I've got a problem in the field. I've got warranty costs that are spiking. Let's be able, for the affected vehicles or the affected products, let's be able to investigate backwards and figure out what was the manufacturing conditions of the day that caused that. And then, by the way, say in an automotive example, it's really cool is that once you say, hey, this was the conditions that was caused on these, for the vehicles that we're having problems with, here were the manufacturing conditions of the day, we can actually find out what other vehicles exhibited the same manufacturing characteristics, and we call only those vehicles, right? So that you actually, it's a containment action, right? You could actually limit the scope of service campaigns. So quality event forensics analysis is a use case we see all the time. We see equipment predictive maintenance being the use case. So again, once you're storing all this information, you can start to figure out what were the factors that actually drove which factors actually predict impending equipment problems. And you can also look at it from a broader perspective in terms of which combinations of equipment events actually impacted overall plant throughput. But so again, storing all this data allows you to answer more and more complex questions. And then the big one is really quality and yield optimization, where you're really starting to see, and I'll give you an example in a second of this, once you have stored this long histories of data, you really are then able to go back and introspect and say, hey, what were the factors, what were the variables that drove either successful or unsuccessful quality outcomes or yield outcomes? And it's a great use case. Let me give you a great example just to illustrate this quality and yield case. This is from a leading pharmaceutical manufacturer that we do business with. And I don't know how many of you are familiar with pharmaceuticals, but at the end of the day, the yield, meaning the amount of vaccine that I get out of a batch, and the yield is basically how much output I got from a given set of inputs. The yield is very highly correlated to profitability, right? So, a small change in yield drives, a lot of profitability, and this is why pharmaceutical manufacturers are really trying to optimize their yield. Well, prior to data lakes and machine learning, this manufacturer was struggling to get a handle of why. And by the way, it wasn't that they were unique. Pharmaceutical companies are always trying to improve the yield. But they were struggling to figure out which factors, which of the many of the literally thousands of manufacturing factors, such as what day of the week, what was the alkalinity of the test, what was the temperature, what was the pressure that we applied when making these batches. They're trying to figure out which factors actually drove yield. And prior to a data lake, this was done manually, one variable at a time, and on spreadsheets, and the human mind, the human data scientist could only consider one or two batches at most. Well, enter the world of big data analytics, and they set up a manufacturing data lake. They loaded all their data into Hadoop from all of their sensor data, from every batch ever made, right? And they actually considered all of that data. So they, like I said, they literally had thousands of sensors, and they were producing this batches for years. They put all of that data in, and they ran machine learning algorithms to determine which factors actually correlated to yield outcomes. And after 5.5 million batch-to-batch comparisons, and just think about that. This is machine learning in action, because the machine's doing this, is looking through each one of those variables one at a time and in combination. They actually, after 5.5 million batch-to-batch comparisons, only then did they discover the characteristics that closely correlated to yield. Okay, and this is just a cool slide that just shows, just some of the graphical analytics that you can use that helped pinpoint and highlight which factors led to it's a good yield, correlated to good yield outcomes. Okay, another example is a company we work with, Nissan. Again, what they say, they wanted to be able to do that quality and forensic analysis that I talked about earlier. They set up a manufacturing data lake. They started pulling in quality information. They started to pull in connected vehicle data, because what they really wanted to be able to do was do what I said earlier. They wanted to be able to detect problems really quickly. So they pulled in service repair data, from their call centers and from their dealerships. So they could detect, they pull all this information in and pull in connected vehicle data. So they could detect a problem really quickly, okay? And once they detected the problem, they wanted to be able to drill down to and by the way, this is a journey, like lots of companies are doing, right? Detect that we have a problem, and then they started to load manufacturing data into the data lake, right? And then say, okay, if we have a problem with a certain set of vehicles, let's drill down to the manufacturing conditions of the day and determine why that happened to those particular vehicles. Then we can actually say, hey, if we understand the conditions that led to that, what other vehicles exhibited the same conditions of that, that occurred on those vehicles? And they could actually then be able to say, okay, let's identify those vehicles that had that were manufactured under the same characteristics, and let's recall only those vehicles. So it became a containment problem. It could contain the service campaign. So again, this is a huge issue in the automotive industry, and companies are getting value from data lakes. Again, this is just another representation of it. Again, take all of that information, the voice of the customer, the voice of the vehicle, the voice of the factory, put it into a data lake and solve enterprise problems, like being able to identify, contain quality problems. So, I've talked a little bit about enterprise data lakes and how that enables next generation big data analytics. I wanted to turn it over to my colleagues who are going to go in this order. We're going to talk to Symetric, who's going to talk about how they can help provide the data lakes with what I'm going to call high fidelity voice of the factory data. Okay, and I'm going to turn it over to Wayne in a second. After Wayne's finished talking about the voice of the factory, we're going to turn it over to Jordan Marks, who's going to talk about how we can actually create what we call the Industrial IoT data pipeline, allowing you to very easily populate that data lake with all kinds of information. So with that being said, I'm going to turn it over to Wayne. Wayne, it's all yours.
Hey, thanks, Michael, and welcome to everybody out there. My name is Wayne Summers, and I am one of the QualityWorks data specialists at Symetric. So my role is to support the data connectivity, integration, management, analytics needs for our Symetric's customers and prospects. So my background is primarily on the data side, the application side of manufacturing, as well as pretty extensive background on enterprise solutions and integration activity. So again, the whole topic of this is how to get data from the plant into a data lake. So, I've heard this term before. It's like, hey, I want to get the shop floor to the top floor. And primarily that's kind of the goal today, is what customers are trying to figure out. So I want to say, and this is the pressure for a lot of you, there's some of you obviously in the plant floor engineering community, but there's a lot more of you on this call that are supporting systems of record, like ERP activity, PLM activity, that's product lifecycle management, supply chain. We have a couple legalese on the call. I promise most everything I say is true. And, we have folks from marketing and procurement and much more. So again, welcome to all. So and the slide here I say the industry Internet of Things, or Industry 4.0, it's time. And it's time to extract meaningful manufacturing data for the enterprise. And what I mean by that is you can't really throw all the data over the fence. You know, you folks in the manufacturing community, you know your data and you know what the challenges are on a day-to-day basis, and you certainly understand the changes in that environment and the injection of new technology and things like that. So part of the job is you understand what you're doing, but you also have to understand what others potentially are going to need. For organizations to view multi-divisional data to make decisions from. So that's what all the push is about, is, you know, there is need for looking at things cross-division and into, in this case, a data lake to make proper decisions. Again, I'll just sidestep here. I've never seen the best and most complicated Excel applications in the world other than in manufacturing. So it is, they use it a lot, and they'll still continue to use a lot, but you know, if maybe part of that can give it a rest, it's a good thing. Give SharePoint a rest. I've seen SharePoint, and it's a great product. They're both great products, but sometimes you can tell how it's used cross-divisionally, if you will. And part of what we're trying to do, that's never going to go away, but is to understand that there is value for putting data in the data lake and making meaningful decisions for the corporation, for the enterprise. And again, the segue is, hey, divisional KPIs to react upon. Instead of having KPIs in each division or each individual, the purpose of a data lake is to make collective decisions. And from that data, corporate-wide KPIs can be created. And you want to provide, as I mentioned, meaningful real-time plant floor data for your PLM activity. So, you know, project lifecycle management, for those that aren't aware, they're the individuals that are responsible for, let's say, in an automobile concern, model year, 2019, 20, 21. They really want to know what's going on the plant floor. If there's something that they can get reasonably quick, and it might require them to make changes on what they have in the CAD systems for these other products that are coming forth. You want to have meaningful data for meaningful discussions with your supply chain. Yes. Okay. In the plant floor, you obviously know what comes in. Having real-time data in a collective manner, you're able to have discussions if there's some concerns or issues with parts, components, and things like that. And you want to provide procurement with supplier report card. You know, if there's some things, if a particular supplier was good for 11 months, but hey, 1 month out of the year there were some issues, the supplier should have that information and be able to look at that data and visually look at that data to have a discussion when it comes time to renewing a contract or pick another supplier. And you want to provide legal and marketing with what they need to address potential recalls. And you want to have this readily available because, to a certain extent, because when a recall happens or something, you want to be able to grab information quickly, at least a baseline level of information, so the enterprise can react accordingly. And, you need, obviously, for recalls, you need to have a basic, and for the folks in manufacturing, you need to have a basic understanding of the data needs of other company systems. And you need to use this understanding to provide meaningful subsets of your manufacturing data to support these needs. So it's time. So let me just go over a quick commercial. Again, I'm with Symetrics. We're a global player. We've been in this space for some time. We're a pioneer with in-process testing, and I should say with in-process real-time testing. And we've collected data and created value part history of what is produced for our customers for over a decade and a half. We pioneered addressing Industry 4.0 requirements. We were creating history even before they started coining this phrase. And we have exceptional leak test capabilities. We have partnered with a company called Cincinnati Testing Systems, CTS, and collectively our combined organizations, we have the best leak testing products worldwide. Over 8,000 systems deployed in the world, and we've been in business for 37 years. And we have a very unique collection and rendering capabilities of our data, and we have exceptional engineering and technical talent. So a sample of where we live, just briefly, this is just, I didn't want to kill you with more than one slide of this, but just to kind of give you an overview, for Ford Motor, we test and record data for every engine made by Ford worldwide. We test all of Aston Martin's engines. We have tested every HP inkjet cartridge since 2004, and that's like millions every year. We're specified as a manufacturing data management and analytics solution for John Deere. We provide data management and analytics in the manufacturing of Jaguar Land Rover engines. And let's see, we're also specified as data and analytics solutions for Honda engines in North America, and there's much more. So this is my single slide on a definition of Industry 4.0, or the Industry Internet of Things. And as indicated, hey, this didn't come from me, it's from the Manufacturing Leadership Council. And most of you folks on the plant floor know about this. For those who aren't familiar with this, you need to understand what's involved, and you also need to understand what's evolving, because not everyone is fully addressing what comprises this yet. And there's a direct impact, obviously, of what is changing on the data and quality of data that's potentially would go into a data lake. So even more so, the amounts of data, the type of data, you know, if we were to start today, it'll be different tomorrow. It'll certainly be different a year or two from down the road. So, so what's the key goals? And just getting back on what Michael said earlier, you know, you want to try to do this as in real time as possible. You want to have visibility into the process, and you want to be able to predict on this data and work accordingly. So again, just a simple picture. This is an assembly line. This is actually in a Ford facility. And I just want you to get an understanding, because not everyone on the phone gets what's going on. So as you can see, there's robots in orange on either side. Some of the things you can't see, there's cameras. And on either side, you see devices and controllers and everything else supporting all this activity. There's a wealth of data here. There's data used to manage the robots, and then there is data that is measured and analyzed that is retained for the quality of what is being produced, as in this case, these bodies, these cars are going through the assembly line. So I just wanted here a sample engine assembly process. So for those that aren't manufacturing, you don't need to know the detail. I just wanted to take a snap so you understand just in broad strokes how an engine is assembled. And, you know, there's a logical and optimized sequence to do this. And there's logical groupings of complementary activity that's generally contained in a section. And within the section, there are logical and operations that are contained within a station. And in this example, we can kind of visualize, if you will, each row is a section and each box will represent a station. And within a station are various operations are performed. okay? And here at Symetrics, we gather all of that. So as product goes through an assembly line process, in this example, an engine, we are constantly gathering data for that serialized engine, if you will, and we have a full part history or birth history of what is taking place. So this is of value, especially in a data lake, because, you know, in the case of a recall, let's say for a car, if it's an engine problem, you know, you're able to look at the VIN and you're able to know the engine, and then you're able to, you know, see some similarities of what might come in as, you know, service bay for issues. And the intent is, if you have this stuff in a data lake, you're able to, instead of doing a recall for a number of years, potentially you can isolate it down to that day or that week or just that product. So the Internet of Things, Industrial Internet of Things, Industry 4.0, there's a, you know, a defined ecosystem. And so you don't have to understand in detail, but I just want people on the line to understand and appreciate the complexity involved in an ecosystem. And this is current and what's evolving. So what's in the arrow is kind of what we're focusing on, the three yellow arrows. But obviously nothing goes there or is accessed there unless these other things take place. So, you know, in today's modern manufacturing environment, you have autonomous robots, you know, and they perform tasks with, you know, a lot of autonomy. You have simulations, you know, which is obviously, if you do things and simulate them in a virtual setting, obviously it provides a manufacturer to reduce the time and cost requirements associated, you know, with the testing process. You have, you know, cybersecurity is big. You know, for those of you aren't aware, is hacks are happening everywhere, and certainly there are individuals wherever around the world that would love to hack into certain manufacturing concerns. So, you know, it's a function of everything. The additive manufacturing, that's kind of like 3D printing. You know, you build a component in layers. And augmented reality, you're seeing more of that slowly in the manufacturing environment. And I guess the best way to describe that is, if you watch a football game and it's a first down and you see the 10 yards out, you'll see like they'll put a yellow line. And that's kind of a visual, if you will, of a crude augmented reality. It's just an overlapping of a user's environment with something else. And then big data, and all of you, I'm sure, have heard about this. It's, you know, it's a pool of large sets of data to be analyzed conceptually and to reveal patterns. And again, this is what, you know, having something in a data lake can provide. So here's a selection of connection possibilities. This is a snapshot of what we do. It's also a snapshot of what other organizations could do as well. And this is just an inkling of what you have to gather into a central repository to make sense out of everything. So for those of you that aren't working in a manufacturing environment, it is complex. And there are many cases it's not consistent. So just to get the data in a manner for them to handle things day to day, week to week is daunting, you know, and they understand that. And part of the bridge that has to happen is the rest of the enterprise really has to understand what portions of the data, the connectivity are going to make sense, because not everything that a manufacturing or, you know, facility produces in terms of data is really necessary, or I should say, of value to the data lake. So I just wanted to throw this slide out here. This is basically, without getting, you know, talking too much about digital thread and digital twin, it's basically, I just want to show you that today and this is the U.S. Air Force as an example. They see value in physical and cyber connectivity, if you will, of what goes in the plant floor and tying to other systems. And you notice on the right, and this is something that was done 5 years ago, right? You see data lake and you see AI for artificial intelligence. So, the data lake and AI has been going on for quite some time. And, more and more organizations are stepping up to the plate. So just want to go over kind of a strategy for a factory-wide optimization, again, for the benefit of those not in manufacturing. So for all this to work, you got to monitor, you got to collect and store data, you got to report and analyze, and act and improve upon this. And let's see. Okay. My slides aren't going through. Ah, there we go. Okay. So you want to monitor and measure. So each one of these circles, if you will, would be a monitoring and measuring station or operation, if you will. And you also need to, hang on. You also need to collect and store data as well. You need a central repository or ultimately gather data from other data sources and centrally have it for the plant. And you need to report and analyze. So doing all this is important for what? Well, you want to act and improve upon things. You want to make sure you reduce your error rates. Here, hang on. You want to reduce your error rates, your cycle time, improve that. You want to determine root cause if you have a warranty issue. All of these things are today what a plant floor does with their data. So again, I like illustrations, I like pictures. What I want to talk about here just really quick is the value of what we call a process signature. So at Symetric, we kind of pioneered this. We've been doing this for over a decade and a half, where we take all the data points of something that goes in a station, an operation, and we come up with these waves, if you will, or we call them their waveforms. And it gives individuals in the plant floor the ability to look for anomalies. So, for instance, if you look at the right wave chart, you'll see that there is, in blue, if you will, those are consistent things within the desired tolerances. Anything out that is something that needs to be addressed. So in real time, someone can be at a station and identify these things rather quickly. So what's a process signature? So don't worry about the math here in the graph. It's just, again, a visual representation of data of everything that happens during a manufacturing operation. Visual consistency should display minimal deviations. And the process signature visually conveys the success and process and health of a product. And it does this in real time. So here's an example of electronic throttle fill rates. Okay, so where the arrows are, that's where the measurement occurred. And you see number one, you can't even make it. It's kind of yellow, so I apologize. So this was noticed actually right away. There's a problem, and you really did need a system for that. However, when you look at items 2, or we call those stragglers, those particular items ended up resulting in downstream failures and ultimately high repair costs, because only where the black arrows are were the measurements, the stop pressure, and the start and stop pressure was measured. So in this case, one would change the the test, adjust the test, so these things would not happen. Okay, whoop. All right. So Here's just a view of a single torque operation. On the left side is how we can configure a database. As you can see, it has a logical flow based on the chart I showed you earlier about a plant floor sections and stations. So there's a logical flow. You know, stuff comes into plant. You have some product out the plant. You have sections and stations, and with each station you have operations. And as you can see here, this is just one wave. And if you could overlay this many times, and you would be able to see patterns of how, in this case, this single torque operation moved from product to product in that station. So for folks, again, not in the manufacturing side, these are simple like process signatures at work, and these are some of the activities that take place. And many times, some of this stuff exists in every plant. And here's some of the analysis, hundreds of applications for analysis, signature analysis. So let's discuss vision. In addition to using process signatures, incorporating vision is necessary, especially when one needs to organize and provide manufacturing data for a corporate data lake. And it's the ultimate, we call, common denominator for the enterprise to better understand manufacturing data. So look, if you take raw scalar data in a manufacturing environment and you don't have visual confirmation of health, success, failure, or something in between, it has limited meaning or very little meaning in a data lake. So in a plant, it's really important, especially for key items, to have part history along with vision or illustration capabilities. Again, undisputed evidence of a product's quality state, and again, immediate feedback. So let's look at some examples here. So here is just vision used to read a barcode, and this is a typical item you will see within a plant floor. In this case, in the Symetric case, if you will, we have a camera has a body. They'll take images. Our gateway connects and works with that camera's data, and we pass that data to our database. And so that's how we interact with the camera. Let's see. Okay, so as you go down the line, that was, we're now analyzing a piston ring. And vision is used to inspect, this portion of an engine. And again, all the data is retained, and everything is logically flows based on defined section, station, and operations. So waveform trend analysis. So what I want to say about this slide is this waveform signatures with pictures can provide a more kind of comprehensive story. So in this example, you're seeing the analysis of a bead of silicon, okay, in where the highlighted blue points are for transmission sections, okay? And if you take a closer look at the example, you'll notice the bead of silicon there's a certain pattern. Technology with cameras and with software, in a plant floor, you can determine the coverage, the thickness, the width, the height of this silicone. And based on prior usages or, application, I should say, what is acceptable and what isn't. And you're storing all this data. So let's just say, for example, this process or this happened in a station, and a forklift bumped something in the assembly line, and it may have caused a deviation to the silicone in this particular example. So it may be within acceptable range or the KPI range that's established, but months pass down the road and a vehicle with this transmission, or a handful of vehicles that might have been affected, end up showing up in the service bay, okay? So using the data retained in our case, QualityWorks database, you have the ability to pinpoint only the effective engines, or in this case, powertrain. And of equal importance, you can adjust your manufacturing process and associated KPIs, making sure that the new range is acceptable and is tighter. Okay, so let's summarize. So again, it's important to understand the manufacturing environment in order to use the data it generates for an enterprise data lake. In turn, it's important for those with a manufacturing environment to take the time to understand what the enterprise could possibly need. Because if you just dump raw manufacturing data in your corporate data lake, you will set yourself up for a lifetime of explaining to do. Being more direct is important for enterprise divisions to come together, have the appropriate discussions regarding your data needs before engaging those in IT responsible for managing your data lake. And once all parties are in agreement, the frequency to populate the data lake needs to be automated. And finally, everything changes over time, so you need to have communication paths to address these changes. And I thank you. I will turn it over to Jordan.
Hey everybody, so thanks everyone for joining us. I know when we're talking about the automation, we have to bring all this together. And I want to wrap this up in a clean way to show you a live demo of how you can use, for instance, the Hortonworks platform, the Hortonworks data flow platform, the Intuitive Replicate tool going against a real-time database containing this information. And why do we all get together? What's the use case for assessing this level of complexity and bringing this all together? When we talk about our tool set, we're bringing the data set from one of these relational databases to the data lake itself. And we're allowing it to be a streaming entity and persisted over time and make it very easy to use. So the Replicate tool is very easy to work with. That's one of the things that we often promote when we talk about it, and manage. And for the ingest, you got over 500 different sources and targets that you're dealing with. So what you're bringing together is the ability to take all these data types and move them over time, and even tools like SAP from the data model, map it. Later on when we discuss this, what I'm doing is I'm taking a bunch of these DB2s, SAPs, Teradatas, all that historical data, and then taking in all these different kinds of sources, flat files, which I'll be taking today, and a SQL server, which I'll be moving into a data lake over here. From there, that data supply chain becomes part of the story that Wayne's talking about. That complexity of resolving these details and arriving at these customer value propositions becomes the foundation of building what we often describe as not just customer analytics, it's a 360 around the product lifecycle and the industrial for IoT use cases, that IIoT that we were talking about. So in here, I'm going to take a very simple example of moving through what we would otherwise have machine data, but looking at the event to act and looking at inventory, ingesting from that relational source, bringing in the Hortonworks data flow tool, NiFi, with the Tunity, gives you the ability to be compliant, gives you the ability to understand, which is part of their Atlas story, data plane, bringing it into driving that business intelligence use case. Looking at the clicks and looking at all kinds of different stories, this is part of that overall supply chain analytics use case inside the demo. So there's a book out there you guys can read, but let's hop right to the demo. So in my environment right now, I've got a number of different sources and targets. This is the Intuitive Replicate tool. I have DB2s, Oracles, and some of these customers we talked about joint. In this use case, the Symmetric tool I'm using is a SQL server right here that I'm pulling from. Grabbing from the database, extracting from the transaction log. It means it's something consistent and something repeatable that folks can pull from. So I start to collect a number of these different tables. So I grab these tables and I pull them over. So right now I'm going to start bringing over those data sets. And these three tables are the reference data that you're looking for to load into a couple 100,000 records to support that overall transactional information. So right here, I did it into Hadoop. Now I created a real-time use case using Kafka for that data. Inside my data sets right here, I've got a number of different items. So I'm going to pull in this Symmetric folder right here, and I've got different data sets. I pulled in these text files, and now I've got all these Symmetric files right here, the part history. Those part histories can be opened up using the Symmetric Studio that we can look at right here, and you can start to look at the different data sets as you're running them. So I took all those files and I used Apache NiFi, the part of the solution that drives a lot of that transition into the Hadoop platform. In Hadoop, you're replicating files and you're storing them. So I'm going to load this up, and I've put a bunch of the data into the overall system, and I've filled up my server, which means I'm doing a lot of activity with it. But you have different sources you talk about. We're processing using Hive processing. We'll later use Spark. But NiFi is a service. I go to the quick link right here. And NiFi is the same tool that you hear about that the NSA, that its roots come from there, of being able to pull and process data. In the Hadoop ecosystem, it started with a lot of coding. Now this gives you a nice, easy to use processor, which is one of the things we're going to do. I drag this on here, and I can connect and consume from XML files. I can pull in messaging, emails, read all kinds of different things. This does very powerful ingestion for different use cases. Now that I've taken SQL Server data that's not only reference data, but I've ingested that into Hadoop, at the same time I was able to get a file that's on the local file system. So as I look at it right here, I'm taking in the properties, and I'm just taking in that Symmetric folder, all of this data that's right here, these Symmetric engine files, and I'm pulling them in and just dumping them into the HDFS ecosystem. Very simple, but I'm putting it into my user opportunity file system. From here, you're going to see that I've dumped them into these files in the Hadoop ecosystem, and they're ready to be analyzed. So I go to my user, opportunity, and all those files that you see inside those files that are part of this ecosystem are driving that to completion.